Assalamualaikum, good morning everyone. Today we are from group 3 want to explain about a little bit from mathematical economics. Here I am with the material differentiation. The first is differentiation have 5 rules. The first is constant rule, general power rule, the product rule, the quotient rule, second derivative, and chain rule. But in this video, I will explain you about the five, rules of it. The first is constant rule. So the constant rule is if you have just a constant like 1, 2 or else, but didn't written with the variable like x, b, c or whatever it is, so it is equal to 0. Here's the example. Here we have the formula x equals 20. So if you derivative it, you have 0. Okay, the next is general power rule. So for the general power rule, here I have the example. So for the formula is if you have ax to the power of b, you have to multiply it by the power. So a times the power of b, and then the exponent is minus by 1. So here we had 7 times 1 because there is a number, so it is 1. 7 minus 1. So there is a constant, so it is equals 0. So the final is 7 the power of 6. Okay, the second is so here you have a root and 1 per x to the power of 2. So these 2 is you can equal it like this. So the final is equals 12. I'm sorry. 12. And then we have the product rule. So the formula is the derivative of u times by v plus u times by the derivative of v. So here we have two functions, and here is the u and is the v. So the first thing first is we must the derivative the u and v first. So I will make like this. There you have the final answer. And then the last thing we have number 4 is we use the quotient rule with the formula is u the derivative of u times by v minus u times by the derivative of v divided by v the power of 2. So, and here is the u and then is v. So we do the same thing as before, like we do the derivative the u first and the v first. Like this, and then we input it to the formula. So here is the final answer. And the last one is the second. The second derivative is the symbol is the second derivative of its function. Here we have example. So this is the first derivative, and the second derivative is derivative once more from its final answer, like this. We have or maybe another example is with this. So here is my simple explanation about differentiation, and then for the next materi we'll continue by my friend.
So the next materi is application of derivative. Marginal cost is the first derivative of the total cost function. The formula is MCQ equal D per DQ TCQ. Example, TC equals Q squared 3 minus 3Q squared plus 4Q plus 4. Determine A. Marginal cost function, B. Average cost function, C. TC, MC, and AC if 5 units are sold. So the first A. MCQ equal D per DQ. This is TC. Q square 3 minus 3 square plus 4Q plus 4. Derivative MCQ is 3Q square 6 minus 6Q plus 4. This is like this because square 3 move to this, and the square minus 1, so 2. So this is like this, 6Q because 3 times 2. And this is why nothing Q because the Q is nothing. And B is IC equal TC per Q equal Q square 3 minus 3Q square plus 4Q plus 4 per Q. Why per Q? Because this is average cost function. IC equal Q square minus 3Q plus 4 per Q. Why this is like this? Because this is the average variable cost that increases with increased production. And 3Q, this is increases decrease in cost due to efficiency at a certain scale of production. And 4, this is a constant average variable cost. Why 4 per Q? Because this is the average fixed cost. Average fixed costs are costs that do not change regardless of the mode of production. As a quality Q increases, this average fixed cost will decrease because the fixed cost is spread off among more units. So the last C, TC Q equal 3Q square 3 plus 4Q plus 4. Q change with 5 because if 5 units are sold. Equal 3 times 5 square 3 plus 4 times 5 plus 4 equal 125 minus 75 plus 20 plus 4. The result is 74. And MC Q equal 3 square 2 minus 6Q plus 4. MC 5 equal 3 times 5 square minus 6 times 5 plus 4 equal 75 minus 30 plus 4. The result is 49. And the last is IC. IC. IC equal Q square minus 3 square plus 4 plus 4 per Q. We just have to change Q. 5 square 2 minus 3 times 5 plus 4 plus 4 per Q equal 5 square 2 is 25 minus 3 times 5 is 5D plus 4 and 4 per 5 is 0.8 and the result is 45.8. The second is marginal revenue. Marginal revenue is the first derivative of the total revenue function. The formula is MRQ equal D per DQ TRQ. Example, CR equal 80Q minus 6Q squared. Determine A. The marginal revenue function. B. MR when 3 units are sold. The answer A is MRQ equal D per DQ. This is TR 80Q minus 6Q squared. And the result 80 minus 12Q. Why this is can 12? Because 6 times 2. So the last there's B. MR when 3 units are sold. We just change the Q to the Q with 3. MRQ equal 80 minus 12Q. MRQ equal 80 minus 12 times 3 equal 80 minus 13, 6. The result is 44. The third, there's elasticity concept. Price elasticity of demand is the percentage change in the quantity of goods or service demand divided by the percentage change in price. Elasticity concept is AD. Bigger one is called elastic. AD smaller than 1 is called inelastic. AD equally 1 is called unitary elastic. AD equal 0 is called perfectly inelastic. AD equally infinity is called perfectly elastic. Elasticity, there's two concepts. Step 1, price elasticity demand. Percent change in quantity per change in price. Step 2, per change quantity equally Q2 min Q1 per Q2 plus Q1 per 2 times 100. And percent change in price equally P2 per P1 per P2 plus P1 per 2 times 100. So the formula elasticity is AD equally D dQ D per dUp time P per QD. Example, QD equally 4 minus P. P is 3 and QD is 3. QD equally 4 minus P. Derivative is QD is dQ per dP is minus 1. AD equally minus 1 times 3 per 3 equally minus 1. AD equally minus 1 to 1. So as AD is college unitary elastic. If price is 15, QS equally minus 200 plus 7 times 15 x square is 1375 UQS per dp equally 14 times 15 equally to 210 ES equally DDS per dp times P per QS equally 210 times 15 per 1375 is 2.29. Okay, thank you. If price is 15, QS equally minus 200 plus 7 times 15 x square is 1375 UQS per dp equally 14 times 15 equally to 210 ES equally DDS per dp times P per QS equally 210 times 15 per 1375 is 2.29. Okay, thank you.
Hello guys, my name is Ibrahim Dwiavrian. You guys might have heard my friend material before me, and now this time is my material, which is partial differential. You guys need to understand that for us to understand partial differential, we must at least understand the basic of derivative. Let's say we understand derivative and the basic of it. We can continue in this material. First, partial differential have a lot of type. One of the type was partial derivative. Partial derivative is when we have a function of more than one variable like y equal f parenthesis x z. We use partial derivative to see how the function change with respect to one variable while keeping the other constant. For example, the partial derivative with respect to x is written as fx parenthesis xz. The second, the partial derivative with respect to z is fz x in parentheses xz. For example, suppose we are given a multivariable function like y equal f in parentheses xz equals x power of 3 plus 5z power of 2 minus 4x power of 2z minus 6xz power of 2 plus 8z minus 7. So how do we answer this? Just like how I told you before, partial derivative with respect to x. Fx in parentheses of xz in equals uh, partial y per partial x. This is basic, but you need to understand that actually how to answer this is we only need to find the one with uh, the x, in the mathematical question, like x in the power of 3. Like how we answer this in derivative is that uh, the number 3 we times with we we place it before the x, and then we get 3, and because we change this means that 3 minus 1 equals 2, so we got 3x in power of 2 minus now why don't we use the 5z power of 2, because is it's including in the partial derivative with respect to z, because it has the z, it doesn't have x. Now minus 8xz, just like how I told you before, it has x. All we had to do was this 2 times 4 equal 8. Because we only use 2, we can remove it by minus 1. That means 8xz minus, we can remove the x because it's 0, then z in power of 2. Same with z, same with z. 2 times 5, that's 10. Because we only use 2, we can remove it by minus 1. That's 10z minus 4x in power of 2, because the z is gone. Minus 2xz, just like the previous with respect to x. You can go and times the 2 and the 6 minus 1. The power minus 1, that means that, and the 8, because the z is gone, that means only the number. That's how we found the basic of the partial derivative. Second, we have total differential. This one, all you had to do was, the total differential shows how y change when both x and z change by a small amount. It's written as dy equals fx in parentheses x z dx plus pz in parentheses x z dz. Like this, we can use the previous partial derivative for the mathematical question. All we had to do was just insert the fx part, which is the partial derivative with respect to x dx plus the partial derivative with respect to z, and this is the answer. We only had to do like this. Okay, this one is a bit harder. Economic application, marginal and cost elasticity. First, we must know how to interpret the elasticity with this note. If elasticity greater than 1, that means it was elastic. If elasticity equal 1, it means unitary elastic. If elasticity lesser than 1, it means inelastic. Now, if elastic AB lesser than 0, it means complements. Usually, usually when it comes to complement, the number is the same. Now, while the substitute, sometimes number is different. Okay, for substitute, it's elastic AB is greater than 0. Okay, cost elasticity. Suppose the demand for good A and B depend on both their price. Okay, QDA equal F in parentheses of PA PB, QDB in equals F PA PB. We can define for the marginal demand, we can define partial QDA per partial PA, how demand for A change with on price, and partial QDB per partial PB for B, always back, okay? While the partial QDA is a cause effect of per partial PB is a cause effect of B partial demand for A, and partial QDB per partial PA is vice versa of like this. So if it's for B, then this one is is for A. Okay, so partial demand elasticity. Partial elasticity together is the NDA. Sorry, elasticity dA equals parenthesis partial QDA per partial PA times parenthesis PA per QDA, and ellipsis AB equals partial QDA per partial PB times parenthesis PB per QDB. Okay. Example. The demand function for good A and B are represented by QDA PA times 2, PB times 3 minus 1 equals 0, and QDB PA times 3 PB minus 1 equals 0. What is the elasticity of demand for each good, and what is the relationship between the two goods? That means we need to find the elasticity of demand for good A and good B, then the relationship elasticity between the two goods. First off, that means there are two demand functions for goods A and B. Goods A are QDA PA power of 2, PB power of 3 minus 1 equals 0. Goods B QDB in parentheses PA times 3 PB minus 1 equals 0. So first off, we need to express the demand function. For goods A, we got QDA PA times 2 PB times 3 equals 1. To answer this, all we had to do was to make the 1 as a per. 1 per PA power 2 PB power 3. We can rise the both of these PA and PB to the top. That means the power become minus. Same for the goods B. Okay. First off, we need to explain the equation A. First, we need to treat the PB power minus 3 as constant. Let's look at this because we use the equation A mean that we use the PB. Let's need to find the equation A. Okay. Partial QDA per partial PA equals D per DPA. In parentheses, PA power minus 2, PB power minus 3 equals PB minus 3 times D per DPA parentheses PA power minus 2. D per DPA in parentheses PA power minus 2 equals minus 2 PA power minus 3. Okay, that's how we get it. And then this partial QDA per partial PA equals minus 2 PA power of minus 3 PB minus power of minus 3. Okay, so that means we already have the partial QDA per partial PA as equals minus 2 PA minus 3 power minus 3 PB power minus 3 with the QDA at the top, PA power minus 2 PB power minus 3. Now compute NDA equals in parentheses minus 2 PA power minus 3 PB power minus 3 times in parentheses PA per PA power minus 2 PB power minus 3. Let's simplify first. Let's simplify the PA per PA power minus 2 PB power minus 3 first, okay? It's like this. PA power 1 minus in parentheses minus 2 times PB 3 We got the answer PA power 3 PB power 3. Then we insert it back. In parentheses minus 2 PA minus 3 power minus 3 PB power minus 3 times PA power 3 PB power 3, and then get this for the multiply at the NDA for the elasticity dA minus 2 in parentheses PA power minus 3 times PA power 3, then another parenthesis PB power minus 3 times PB power 3 equals minus 2 times 1 times 1, then and the answer we got minus 2. Or there are simpler to get this, and that is to use the PA as 1, and then we can because both of the number are the same, we can now just remove it because it's the same number, and then we got minus 2. Same for the equation B. If you guys know how to do the equation A, then the how to do the equation B will be the same. The only difference is we use PA power minus 3 as a constant. See, the answer is the same, and even the simpler how to do it simpler was the same, and that is to change the PB to a 1, and then we move the same number. Okay, so we got the answer. Equation B, we got minus 1, and for the equation A, we got minus 2. That means good A is elastic because elasticity dA minus 2 greater than 1. Why is minus 2 greater than 1? Because in elastic, it doesn't matter if your number is minus, it's always going to be positive. For example, if it's minus 2, that it means 2. If your number is minus 5, that it means 5. Okay, so this once it should be good B is unitary elastic because the elastic dA dB is minus 1 equals 1, just like I told you. Minus in elastic meaning positive. Okay, it doesn't finish because we haven't found the relationship between the two goods. Now, to get the relationship between two goods, we can use this. Cos pi elasticity good A, cos elasticity A with respect to B is that we can use this. Partial QDA per partial PB equals minus 3 in parentheses PA in power minus 2 PB in parentheses PB power minus 4. The how to do it is just like how we used to do it previously. This is a simple one. We can use it like this. Okay, all we had to do was removing the same number, and we get the minus 3. Same with goods B, just the difference is we use, it's the same. Now, because the answer cos plus elasticity, so answer cos plus elasticity, because good A and good B elasticity AB is 0, because minus 3 is 0. Okay, for cos plus elasticity, minus is minus. It doesn't change. Okay, and that's why elasticity AB is lesser than 0. Okay, so and the elasticity AB is minus 3. Okay, that means it's a complement. Why? Like I said previously, complements mean that the answer for both good A and good B have the same. It complement each other. If one goods reduce in something, then both of the good will rise in demands. Okay. Okay, so that's all for the basic of partial differential. I hope you guys understand this material. Thank you very much.
The next material is about matrix. What if a matrix? A matrix is a collection of numbers and arranged in rows and columns and placed in bracket. Example, matrix A, the vertical line is first row and the second vertical line is 2 rows and the three vertical line is 3 rows and the horizontal is first column, and this is 2 column and this is 3 column. And the next is type of matrix. Matrix have 4 types. The first is row matrix. Example, matrix A 0, 3, 4. So this is like vertical, and second is matrix column. Matrix column is like horizontal, and the square matrix, like example A, matrix A is 8, 5, 2, and 7, and the last type is diagonal matrix. Matrix P 2, 0, 0, 4 and Q 3, 0, 0, 0, X 0, 0, 0, 5. So the next is about matrix number operation. This is calculation about operation number. And example, if A equation is what if A plus B, then A plus B. So the first is 1 plus 7 and 2 plus 8 and 3 plus 9, 4 plus 10 and 5 plus 11, 6 plus 12. And the answer is 1 plus 7 is 8 and 2 plus 8 is 10 and 3 plus 9 is 12 and 4 plus 10 is 14 and 5 plus 11 is 16 and 6, the last is 6 plus 12 is 18. And next is what if A multiply B? Example, 1 multiply 6 and 2 multiply 9 and the vertical and the row multiply column and 1 multiply 7, 2 multiply 10, 3 multiply 6 and 4 multiply 9, 3 multiply 7 and 4 multiply 10. So the answer is 1 multiply 6 plus 2 multiply 9 is 24 and 1 multiply 7 plus 2 multiply 10 is 27 and 3 multiply 6 plus 4 multiply 9 is 55 and 2 multiply 7 and 4 multiply 7 is 96 and 91 and 61. Sorry. The next is about determinant matrix. Matrix A, B, C, D, and determinant A is A multiply B and min B multiply C. Example, matrix B 2 multiply X is 16 and 4 multiply 5 is 20 and 16 min 20 is min 4. Question, matrix A determinant the determinant A, and the first is 1 multiply 3 and multiply X is 24 and 4 multiply 5 and 5 is 100 and 6 multiply 2 and 4 is 48 and 6 multiply 3 and 5 is means 19 and 1 multiply 5 and 4 is mean 20 and 4 multiply 2 multiply 8 is mean 64 and the answer is mean 2. And the next is about adjoint matrix. The adjoint matrix have a formula is adjoint multiply A equally A adjoint. Example, suppose A is 1, 2, 3, 4, 5, 6, 7, and 8, and determinant is 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer is M11 is 5 multiplied 9 and 6 multiplied 8 is mean 3. And the second is M21 is 2 multiplied 9 and 3 multiplied 8 is mean 9 and mean 6. M31 is 2 multiplied 6 and 5 multiplied 3 is mean 3. And next is M12, 4 multiplied 9 and 6 multiplied 7 is mean 6, and 1 multiplied 9 is 3 multiplied 7 is mean 12, and M32 is 6 multiplied 1 and 3 multiplied 4 is mean 6, and last is M multiplied 3 is 4, 8 and 5 multiplied 7 is mean 3, and M23 is 1 multiplied 8 and 2 multiplied 7 is mean 6, and mean 33 is 1 multiplied 5 and 2 multiplied 4 is mean 3. And the next is because adjoint mean 1 E plus J and EJ, then M11, so E plus J is 2 and 2 plus 1 is 3 and 3 plus 1 is 4, and mean quadrat multiply mean 3 is mean 3, and mean 3 and mean 1 multiply mean 6 is 6, and mean 1 multiply mean 3 is mean 3, and then the adjoint of A is adjoint A11 and A21 and M31 like this. So mean 3, 6 mean 3 and 6 mean 12 and 6 and mean 3, 6 and mean 3, and the answer is mean 3, 6, 3 and 6 mean 2, 6 mean 3 and 6 mean 3. That's right. And the next is Mathematic is about Cramer's rule. The formula is XE adjoint per A, and the example is find x1 and x2 using Cramer rule. If 5x1 plus 0, 4x2, 12, and 3x1 plus 3x2 is 21, and the answer is 5, 0, 4 and 3, 3, and x is x1 and x2, and c is 12 and 21. Next is x1 is a1 and a, so 12 multiply 3 and 21 multiply 0, 4, and the answer is 36. Mean x4 per 15 mean 1, 2 is, the answer is 2, and x2 is 5 multiply 21 and 12 and multiply 3, and 5 multiply 3 and 3 multiply 0, 4 is 5. Okay, so the next is about inverse matrix. The formula A power mean 1 and adjoint multiply A and per determinant A. Example, determinant the inverse of matrix A is 8, 4, 5 and 3. The answer adjoint A11 and A12 and A21 and A22. And this is 3 and 8 is switch. They are in switch, and the adjoint of A is adjoint 3 multiply X is 24, and min 5 multiply min 4 is 20. 24 min 20 is 4. And the last is A power min 1 is adjoint per A per determinant A. So 3 per 4 is 0.75, and min 4 per 4 is min 1, and min 5 per 4 is min 1.25, and 8 per 4 is 2. So this is about linear equation using matrix. This is the previous equation, so let's just continue and add C. So the first is search about this. The first is 1 multiply 5 and 9, 2 multiply 6 and 7, 3 multiply 4 and 8, and 3 multiply 5 and 7, 1, 6 and 8 multiply, and 2, 4, 9 multiply. So the answer is 45 plus 84 plus 96 and min 105, min 48 and min 72, and the answer is 0. And the next is about adjoint. So the first step is min 3 multiply 2, and 6 multiply 2, 3 is multiply 2, and min 3 plus 6, oh no, sorry, see about min 6 plus 12 plus 6 is 12. So the answer, the first is 12, and next is 24 plus min 8 plus 24 is 40. 14. Yeah, 40. And min 3 multiply 3 is 9 plus 18 plus min 9 is 0. And the answer is this.